So next, we would like to have another discussion for the AI for sustainability, which is a very important topic for all of us this year. So for next, I would like to invite คุณพงศสิทธิ์ทองประนูน Data Science Solution Architect from NVIDIA, and also Dr. Etienne Muller, Assistant Professor at CMKL University. Please give them applause. Thank you.
Yes, hello. So we keep it a little bit more casual today. It's only the two of us. And so quickly about me, my name is Etienne Müller. I just recently started as an assistant professor at CMKL. My background is in brain-inspired computing, so we try to get like a little bit of inspiration by brains to make neural networks a little bit more efficient. And to my right, we have Pongsasit from NVIDIA, who is a senior solutions architect. And yeah, I would like you please tell us quickly what's your background,
Okay.
and when did you notice that sustainability might be very important in the future?
Okay, sure. So let me introduce myself real quick. I'm Pongsasit, or my nickname is Mod. When we see each other outside, you can call me Mod. So my background is I start my career from data scientist, then be a machine learning engineer, then move to like AI engineer, and now becoming the solution architect. The one point of like professional career, solution architect different from engineer is the outcome base. It's more important than technology. So this one related to how company gonna be sustained. If you invest in something and gain revenue, or use some power consumption to bring the new value. So this kind of thing is one thing that I have to think in my professional career a lot when I am become the solution architect for NVIDIA. Yeah, how about you? Your research about like neuroscience, something neophobic computing stuff.
Yes.
Can you like tell us real quick?
Yes, thank you. So basically my research so far was to try to look how the brain does computation, because the brain only uses 20 watts for everything we do. That's pretty much like a light bulb. Whereas if you have like big data centers that are very far from what we can do with AI today, go more like in the gigawatts. And so that's like very, very huge. And so if we just look at the brain operates way more sparse, and it only consumes energy when it transmits information, which makes it like so much more efficient. Up to we guess, best guess would be like up to 1,000, but that's probably like very far in the future. But yes, so this is a little bit the next generation. It will not be the solution of what we need immediately. And so today everything is NVIDIA, and tomorrow also everything will be NVIDIA. So yeah, I would be very interested in how does NVIDIA use all that compute power, because NVIDIA has produced the chips, has the most chips, and there's so much we could talk about sustainability, but if you produce the chips, what do you do with that? What can you simulate in software to make a better future?
Okay, let me kind of grouping my answer into like two parts. First, NVIDIA do the chips, which is the hardware. We call it accelerated computer. So if you're doing AI simulation, NVIDIA product comes to help. That is first thing. Second thing, NVIDIA also have the software. Anyone knows? Okay, fine. So, okay, NVIDIA also have the software, which I work for NVIDIA software team. So we also do the framework as open source for AI developer to like do the end-to-end AI lifecycle, which like this framework gonna be optimized and make the full efficient of the software integrating with the hardware of NVIDIA. We call it NEMO and NIMS. So yeah, it's fine. So that things, so we have like from hardware to software, and the use case, we let our partner or our user to create. For example, simulation automotive company can bring our hardware and our framework to do simulation for saving costs when they produce something. For AI, for example, agentic AI, we need like reasoning model. You can use our like platform and framework to build your own stuff. The reason why we think about sustain because our customer using like a lot of energy consumption. It's like, for example, you have like GPU rack in one big data center for like producing OpenAI model, for example, that consume a lot of like energy as you mentioned before. If the chips not like increase the efficiency of the way we produce the token, this global warming will be like surge and then everything gonna be high. The cost of the model development gonna be high. So we're taking care of like the next generation of chip, the June per token, that is the unit to like calculate how like energy efficient of the LLM model token generation is gonna be lower in every time the new chips come, like 2 times power of 2 depends on the chips. Yeah, that is like what NVIDIA related to like sustainability. Yeah, Katian.
Yeah, nice. So yeah, from my previous work, when I did my PhD, I actually did my simulations with these brain-inspired networks, and NVIDIA nearly messed up my whole degree because I tried to make networks more efficient, and so it worked. And then NVIDIA introduced sparsity, which made it so more efficient. A paper came out that told that my brain-efficient networks are only efficient enough in a very specific constraint. And so I had to spend 2 whole weeks to run all the simulations again to check if I'm still under this threshold, which I was just barely, but good enough to get a PhD. So that was good for me. But I think the next little breakthrough would have really broken my neck. And so I would say sparsity was one of the big things how NVIDIA improved the efficiency of GPUs. And also the tensor cores that are used are like just pure genius, to be honest. And I would be interested, what is in the current generation, what makes them more efficient, and do you have a hint what's coming next? What will be the next big thing?
Let me tell the current, I mean the now first. So since I am the software person, right, the framework we also have the way to deploy the model more efficient than ever. For example, you may use open source to deploy your model and inferencing with some ABC framework. I will not mention the name. If we use NVIDIA chips, which that framework also use NVIDIA hardware as well, and use Dynamo framework for deploy the model, the efficiency is going to be 30 times faster. It's similar as like sparsity that you mentioned, like 20 times, 30 times, depends on this model size. But averagely, if you do correct framework on the correct hardware, the efficiency of your model and your system, LLM application system, going to be increased rather than use like vanilla open source stack. This is the first thing that we are doing. We call it Dynamo. The second thing, you may heard about like precision, I mean like lower precision model training. For example, FP8 for like DeepSeek or whatever. Now, NVIDIA have NVFP4, which is like lower precision, and then you can train the model for the smaller memory of the GPU. That one is also make you more efficient to train the model. In NVIDIA, we call it like mixed precision training, which is the way you can like use less energy, less time to train the model which have like big parameters. Yeah, but maybe the accuracy will be less, but the energy gonna be like more or less. So this kind of 2 things in the software wise we are doing now. And then we already released the open source first version last month ago, and the latest version last week ago. I mean, internally in NVIDIA developer team, we try to like release new version every 2 weeks. We try to, yeah. So it's gonna be like majority of like researcher who want to use like mixed precision training from now and so on. I think these 2 things is what like I can mention as of now. Yeah.
Nice, thank you. Yeah, so another topic I would like to talk is the biggie, the data centers. So I have a couple of numbers, and so for example, if you use ChatGPT nowadays, one ChatGPT query uses 10 times more energy than a Google search, and for 1,000 queries, you emit as much CO2 as you would with a car driving 400 kilometers. And last year, Thailand consumed 224 terawatt hours in total, and all data centers in the world are already at 415, so nearly double. And by 2030, it's projected to be 945, so more than doubling again. And so I don't want to point fingers on NVIDIA because that doesn't make sense. Because there's, we just looked it up again, there's something called Jevons paradox, which states that when efficiency increases, then the resource consumption also increases. It was actually coined back in the days of steam engines. So when they figured out that when a steam engine got more efficient, they actually used it for more applications, and therefore more coal was used. And so we're basically at the same point when NVIDIA releases a new generation, it gets more efficient, but companies are not like, oh, we can run GPT-5 on half the energy. They're just like, oh, let's pump out GPT-6 with double the compute. And so yeah, it's we cannot say that that's the case. But if we have all this compute, we were talking about the weather simulation, and so NVIDIA has the most compute because you're building it. And could you tell us about the simulation that you run with that?
Okay, thank you for your question. This room is getting warmer after this question. So let me answer you this way. First of all, from the hardware wise first, if you in NVIDIA hardware we have the generation, the like older generation we have like H100. H is from Hopper, and B is for Blackwell. Let me like compare from the older generation and the current like Blackwell 300 generation. The power consumption is 30 times less. That is the first thing. So every new chips NVIDIA produce, the power consumption is decreased. That is one thing that we try. Since we know the energy of this world will not enough for if we use the same architecture and if we use the same like generation of chips, we cannot create the new like innovation using AI simulation, whatever stuff. That is the first thing. Every new chips, energy consumption is less. Grace Blackwell compared to like Grace Hopper is 30 times less. That's what like NVIDIA responds for this. Second thing, when we invest, this one is more than not just only like energy, but also if we talk about sustainability, energy is one thing, is environment, right? The people and economic, we have to think about that too, right? If we consume energy a lot, but people life and economic growth, I think it has a value to do. For example, the life before AI, before like ChatGPT or Claude or Gemini, whatever you mentioned today, life is more difficult than now in terms of like searching something, doing some job. As of now, it's like people life is easier using AI. It's like not just only the AI that I mentioned, but also the AI tools that have, for example, Perplexity, Cursor. You can produce a lot of new product, so the economy also grows. So if we care energy, yes, we care, since Grace Blackwell is 30 times more energy efficient than Grace Hopper, 30 times. Yeah, and we also like able to produce these kind of new things because in NVIDIA we think the next generation of AI is physical AI, which is robotics. And this kind of physical AI, these robotics things cannot happen if the foundation of current generation of AI, which is agentic AI, the reasoning model, the AI tools, calling, is not happen. So if we see further and which the physical AI come through, you may like have like real autonomous car, like Tesla robotaxi is in the newer version, which is more better than now, something like that, or the assistant robot. We need that kind of like knowledge I mean like the chips for training the model. So if we balance three pillars of sustainability, people, environment, and economics, I think we look at every parameters and we go further in the good shape, in my point of view. Yeah.
Yes. Amazing, thank you.
Thank you.
Yeah, that sounds like CMKL and NVIDIA could start some cool robotics projects together.
Yeah, sure.
Yeah, so I think we already have to come to the end. Yeah, I would like to know, so you work at NVIDIA, which is arguably the best AI company or the most efficient company, AI company at the moment. And so I could imagine that a lot of our students, current or future, would also like to end up at NVIDIA. So if these students want to, say, start next semester studying, what would you give them as an advice? How should they use AI and how should they learn it?
Okay, so first of all, think as engineer. Okay, let me answer this by using like engineer point of view. So for me, if we want to use something, we have to know how that thing works at the back end. So if you want to be a part of which company, for example, NVIDIA, you have to know like how NVIDIA produce the product, which product and how it works, something like that. That is the first thing. The second thing is every company, every organization have their goal. For example, CMKL have a goal to build the world-class student, researcher, and NVIDIA have a goal to like push the AI society into the next frontier. So if we know the goals of each organization, think that we really want to do that goal with the organization or not. If, okay, you want to like be the frontier of like AI ecosystem using like accelerated computing, go for it. And then after that, you can plan your learning because like if you are younger, you have more time and more energy. I think you have back pains after your 30s already, right? But 20s person not. So they can stay long focusing on something and be focused. Because the younger you are, the more chance you have, but the less focus you may be attracted to. So be focused, understand what the organization goal, and like think wisely and decide. The earlier you can decide, the more chance and more time you can practice yourself to adapt to that organization goal. That is my advice for. How about you?
Yeah, I mean, you basically said already everything. I really would say that the use of AI nowadays is basically the great equalizer. It's everybody, basically on the whole world, if you have internet, and Thailand has actually great internet, better than Germany. And so if you have internet, you can actually learn everything you need. You have access to everything you need. There was a time when compute was a problem, so you needed like a good computer at home to run or learn coding. But you can access everything. You can remotely have all the compute that you need. And so you can basically do it from your smartphone. So it doesn't make a difference if you're in Thailand, if you're in the US, or like doesn't matter. Everybody has the same access. So I would say it's mostly the drive and learning the technology. And yeah.
Yeah, I agree with you that AI is the equalizer, and the drive and goal focus individual is different. So yeah, agree, 100% agree on what you're saying.
Thank you. And that's it.
I think we have like 1 minute. Any question before we end? Okay, sure.
So there seems to be an underlying assumption of what sustainability means in this conversation, that it follows from computational efficiency, right? But I'm also thinking about sustainability in terms of reduce, reuse, recycle. So question to NVIDIA specifically, who's producing most of the hardware that's being used for AI nowadays, what happens to the previous generation of the hardware? what use are they when they get retired from data center, for example? What happens to all the crypto mining GPUs, right? What's the support for that, so that we can continue to use preventing these hardwares from going to the landfills?
Okay, let me answer what I can answer first. The things that I can answer is from the data I have, right? The things that I cannot answer, I will leave it because I cannot. So the hardware generation for example, AI training GPU, if next generation come, the consumption to the next generation will be for the next technology or software. But the existing one, which like still able to run, still able to use, this kind of like hardware will be consumed by the like older technology. Because as of now, even we have LLM, we have like VLM or whatever like large model, but the machine learning or deep learning for the like traditional AI is still able to use it. So older generation can enhance those kind of like previous generation of like technology too. So it's not like new ones come, throw old things away. No, the old things can be like value for the other tasks, not like the frontier task. Yeah, that is what I can answer. But for crypto mining, blah, 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 I have no data point, so I cannot say anything is going to be mislead. Yeah, thank you.
Thank you.
That's
ขอบคุณ
it.
ครั
Thank
บ
you.
Thank you.
Thank you. Thank you very much for the AI for sustainability topic. Thank you for คุณพงศสิทธิ์ทองประมูล Data Science Solution Architect, NVIDIA, and Dr. Etienne Muller, Assistant Professor from CMKL University.